Okay, good morning, everybody. So today we're going to continue our discussion in the prerequisite chapter section 4. This is the last video of this section. And today I'm going to cover a couple of things that may or may not be familiar to you. One of which is going to be some more advanced factoring techniques that hopefully you covered last year, but I'm not going to pretend like you did, and I'll cover it from the beginning for you. So, the first thing we're going to talk about is how to factor a trinomial of the form ax squared plus bx plus c. And the thing that's different about this compared to the other videos that I've already recorded on this section is that this lead coefficient right here in front of the x squared is now going to be a number other than 1. So if you recall back in the last video I gave you, where you had things like this, x squared minus 7x plus 12, the lead coefficient was 1. And that made it really easy then to factor this. You simply found two numbers that multiplied to give you positive 12 and then added to be negative 7, in which case this was negative 3 and negative 4. And so you could just split it. You didn't have to go through this long drawn out process of splitting the center term, otherwise known as the ABC method. So, and the reason why you could do that, and this was the other example that we did, the reason why we could do that is that this lead coefficient was 1. And it just allowed us to split this negative 6 into two numbers. We cannot do that for types of problems that have a lead coefficient of something other than 1. For instance, if you look at this one we have right here, we have 6x squared plus 17x plus 5. This 6 right here means that we cannot just split this into two terms like I did. We're going to have to do a more advanced factoring technique. And I've always called it the ABC method. I believe that's what you guys called it last year when you learned it. But what this is showing you below here is all the different ways you could make 6x, right? So 6x can be 6x times x to give me 6x squared. Or I could have 2x times 3x, which would also give me 6x. Here we go with my lights again. I'm sorry. So there's an easier way. Rather than writing all of these out and figuring out which one works, we're going to use something called the ABC method. And the ABC method, in a nutshell, has us split the center terms and then determine which, then factor it by grouping. But we have to figure out how to split the center term. So that's what I'm going to show you now. So if you look at this 6x squared plus 17x plus 5, this shows us that we cannot just find two numbers that multiply to give us 5 and add to be 17. First of all, there aren't any. Second of all, this 6 means we've got to do this ABC method. So the first step to the ABC method is to take the 6 and multiply it by the 5. So it's the first one times the last one. So 6 times 5 gives us 30. And now what we have to do is write out all of the factors of 30. So if you look, I list them here underneath the 30. So 30 is 1 and 30. It could be 2 and 15. It could be 3 and 10, or it could be 5 and 6. Now, the reason why we need to do that is we need to find the two factors that will add up to be the center term. So in this case, they need to multiply to be positive 30, but then they also have to add up to be positive 17. And so if you look down through these pairs, 1 and 30 would not work. 2 and 15 would work. So you can see, since 2 plus 15 is 17, this is the pair of factors we are going to use. So let's recap again. Because this 6 is on the x squared, we have to do what is called the ABC method. The ABC method starts by multiplying the first term and the last term together, which gives me 30, and then we write out all the factors of 30. We have now found the pair that adds up to the center term 17x. Now, here's what we're going to do with that pair. This 2 and this 15 are going to replace the 17. That's what we're using this pair of factors for. So if you watch in the next slide here, I'm going to rewrite this equation, 6x squared plus 17x plus 5. But the 17 gets split into two different terms. It's 2x and 15x. Now, if you were to add those two together, it would, of course, give you 17. And that's the point, okay? But here's what this did for us. This gave us four terms. Now, we have a 6x squared, we have a 2x, we have a 15x, and we have a 5. And anytime you have four terms, if you remember from the last video that we had, is you factor this by grouping. And so that's exactly what we're going to do. We're going to group the first two terms together. I'm going to group the second two terms together. Once I do that, I'm going to take the GCF out of each one of these groups individually. So in this case, 2x is the GCF. So we'll take a 2x out of here. In this case, a 5 is the GCF. So we'll take a 5 out of these. And you can see I took the 2x out. I'm left with 3x plus 1. Over here, when I take the 5 out, I'm left with 3x plus 1. And if you remember from the last video, these two things that we're left with when the GCF is pulled out have to be the same. If they're not the same, you cannot do the next step. So in this case, the 3x plus 1 is exactly the same as the 3x plus 1, which is good. So that's going to get regrouped. One of those is being written, not both, just one. And then we're going to regroup the 2x plus 5. So we end up with 2x plus 5 times the quantity 3x plus 1. Now, what needs to happen next is if you want to check, and you don't have to, but if you would want to, you could refoil this out. And if you refoil this out, you will end up with the original equation, expression, 6x squared plus 17x plus 5. Okay, so here's another one. I want to try. This is example B. So once again, you can see that we have a lead coefficient on the x squared term that is not 1. And when it's not 1, you must do this ABC method. And the ABC method starts by multiplying the first term and then the last term together. So that's 2 times 3. So that's going to give us 6. Now we need to write the factors of 6. Factors of 6 are going to be 1 and 6, 2 and 3. Now notice they're all negative. Let's talk about why that is. If you see right here, I have positive 2 times positive 3 gives me positive 6. So when they multiply, we know the numbers have to be positive. But when they add together, you can see they need to equal a negative 5. So in order to have two numbers multiply and be positive, but add and be negative, you only have one choice, actually. If they're going to multiply and they're going to be positive, they either both have to be positive or they both have to be negative. To add and be negative, they both have to be negative in this case because we don't have any other choice in that. So what that means is all of our factors need to be negative in order to work for this problem. So again, 2 times 3, positive 2, positive 3 gives me positive 6, but they have to add to be negative. So they have to multiply to be positive, they have to add to be negative. Therefore, they both are going to be negative. And so, as you probably know, the two that will add together and give me negative 5 are going to be negative 2 and negative 3. And so we're going to use these two numbers to do just like we did in the last problem. These two numbers are going to split this center term. So the negative 5x will now turn into these two numbers. And you can see that that's what I did right here. So we still have our 2x squared, but then we have minus 2x, minus 3x, and then we have our plus 3 that's still there. Once we have these four terms, we're going to do the same as we did in the last problem. We're going to factor this by grouping. Again, four terms, grouping, automatically. It's what you need to think about. So there is a minus right here. This minus needs to be put directly on the 3, and then we need to put a plus in between the sets of parentheses. Keep that in mind. I talked about that in the last video as well. Now, once we've got our terms grouped, we are going to take the GCF out of each of these. So this one right here, this first grouping, has a GCF of 2x. This one right here has a GCF of negative 3. So when I take 2x out of the first one and I take negative 3 out of the second one, you can see that I'm left with x minus 1 in both cases, which is important because you can't proceed unless that's the case. Now that we do this, we are going to regroup the GCFs that we pulled out, and we're going to write one of the x minus 1s. And you can see I have 2x minus 3, and then I have x minus 1, and it's fully factored. If, again, you wanted to check this, you could refoil this out, and if you did that, you would end up with the original equation, 2x squared minus 5x plus 3. Okay, we have one more to do here. Actually, that's not true. We're going to do two more. So let's do it. Once again, you can see this is a trinomial. There are three terms in this. The lead coefficient is not 1. So anytime you have a trinomial, three terms, and the lead coefficient is not 1, you're going to have to do the ABC method. Just to back up, and I probably should have mentioned this earlier, you should always look to see if there's a GCF that will come out at the beginning. None of these have a GCF, which is why I really didn't mention it, but you really should, anytime you're factoring, the very first step you do is GCF, automatically, first step. So looking here, we have a 12 at the beginning, so we're going to have to do the ABC method, which means I'm going to do 12 times 1, which gives me 12. So I'm going to write down the factors of 12. As you can see, 1 and 12, 2 and 6, 3 and 4. So there's my pairs of factors. Notice that they need to multiply to be a positive 12, but they also have to add to be a positive 7. So if they have to multiply to be positive and add to be positive, they both have to be positive. So which pair out of these three are going to add up to be 7? I think it's pretty obvious that it's the 3 and the 4, right? So now again, we're going to use those two factors, 3 and 4, to split that center term. And so that 7x is now going to turn into 3x plus 4x. As a side note, and I probably should have mentioned this in the other two examples, it does not matter which you list first. You could list the 4x and then the 3x, or you could list the 3x and then the 4x. It will not matter at the end. You will still have the same result in your factoring. So now that we have four terms, we're going to group the first two terms together. We're going to group the second two terms together. And we're going to take the GCF out of each individual group. So in the first one, the GCF is 3x. Okay. Now, in the second one, this is why I showed you this. There is no GCF. So sorry about my lights, guys. This keeps going out. It's getting actually rather annoying. So there is no GCF for this. So the GCF, in this case, because there's not a number that can be pulled out, we need to know that there's still a 1 right here. And this is really important for the next step. So there was no number to pull out of 4x plus 1, but there is still a 1 right here. So when we go to regroup, you need to take what was pulled out. In this case, we pulled a 3x out. Over here, there is a 1. Even though it's not really written there, it's still there. So when we regroup it, you can see it becomes 3x plus 1, and then we write one of the 4x plus 1s. Okay, so this is something that's easy to miss, which is why I wanted to give you an example of this. So if there is no GCF, remember there's a number on the outside of that parentheses that is still a 1, and it needs to be accounted for when you regroup the GCFs together and then write one of the things that are left. So you can see we get 3x plus 1 and then 4x plus 1. Hopefully that made sense. As always, if you have any questions, feel free to email me. Have a good day.